Hi, my name is Hafsa, and today I'm going to be talking about thermal pollution. So you must be wondering, what is thermal pollution? Well, let's get into it.
Thermal pollution is when heat is added to a body of water, increasing the temperature and creating adverse conditions for the survival of aquatic life. You must be wondering why heat would cause such bad living conditions, right? After all, us humans love a little heat to keep us warm. We, or at least I, love when I'm feeling cold and someone throws a blanket on me. The thing is, heat doesn't interact with oxygen and air the same way it does in water. In water, as temperature increases, the concentration of dissolved oxygen decreases. And as we know, dissolved oxygen is perhaps the most important chemical constituent in aquatic environments. As dissolved oxygen decreases, there's a chain reaction. Low oxygen levels stresses out organisms and makes it harder for them to survive. They then die, and decomposition increases, which uses even more oxygen. Once the need for oxygen surpasses the amount available, only anaerobic organisms can survive.
An interesting tidbit is that for every 10 degrees Celsius increase in temperature, the oxygen consumption of aquatic plants doubles. So, to very generally demonstrate the effects of thermal pollution, I've prepared a little experiment that you can do at home with your family. So, let's begin.
So first you're going to need a tank. Then you're going to need some hot water. And lastly, you need a fish.
Before you start this experiment, make sure the fish is well fed. So now what you're going to do is you're going to take some of the hot water that we prepared and you're going to pour it into the tank. If you followed these steps correctly, you should have a dead fish on your hands.
For legal reasons, this segment was a joke. Please do not put warm water in your fish's tank. It will die and you will be sad.
Now that we've talked about what thermal pollution is, I wanted to get into some of the causes of it. One of the main causes is production and manufacturing plants.
Power plants located near rivers usually have two methods of cooling. The first type is called a once-through cooling system, in which the heat absorbed by the cooling water is directly put back into the river. The once-through cooling system has devastating effects on the biota of the water body the hot water is dumped in. As mentioned before, increasing water temperature stresses out organisms and causes a chain reaction in which dissolved oxygen concentrations decrease. The second type of cooling is called a cooling tower. In this method, most of the absorbed heat in the water is removed through evaporation entering the atmosphere. We'll touch on cooling towers later on.
Another cause of thermal pollution is soil erosion. Constant soil erosion can cause increases in sedimentation, which can lead to many negative effects in an aquatic ecosystem.
First, sediments absorb heat radiating from the sun, which consequently increases water temperature, stressing out organisms. Second, sediments can clog fish gills as well as ruin the protective layer of mucus covering scales in the eyes of fish. These both make them more susceptible to death and infection. Third, an increase in settled sediments can also raise water levels, exposing more surface area to the sun, which will also increase water temperature to a certain degree. Lastly, sediment suspended in the water column also present its own issues. High concentrations of suspended sediments can dislodge organisms and plants in the streambed. Deforestation also indirectly increases water temperature. If a river is surrounded by a heavily shaded forest, the aquatic ecosystem is used to a cooler temperature. Deforestation causes the loss of shade provided to a body of water, increasing the amount of light penetration. This in turn increases the water temperature, affecting the equilibrium existing within the ecosystem. By equilibrium, I mean the natural conditions of the aquatic community. Deforestation can also increase soil erosion and runoff, leading to more pollution.
Runoff from urban surfaces absorbs sunlight, therefore when it enters a water body, it increases the temperature. Sewage being dumped into rivers also increases water temperature, as the sewage is hotter than the regular temperature of the water.
Retention ponds are another source of anthropogenic thermal pollution. Retention ponds are also known as stormwater retention basins. These basins are used to store runoff and act as a land drainage system. They act as a filter to remove sediments and chemicals before being drained into the rivers. The downside is that before the water is drained into a river, it absorbs a lot of heat from the sun as the retention ponds tend to be small and shallow. When this significantly warm water is then pumped into a water body, it can cause thermal shock.
Thermal plumes can be horizontally distributed through wind-induced currents. Coastal currents, however, can trap these heat plumes without dispersing them. Therefore, nearshore areas closer to the pollution source are more sensitive. Not all causes of thermal pollution are anthropogenic. I know I touched on quite a few, but natural causes such as lightning, for example, add massive amounts of heat to water. Since I already talked about how thermal pollution affects oxygen levels, now I'm going to take some time to talk about the other effects thermal pollution has. Extra heat can cause mixing regime shifts in lakes, changes in nutrient cycling, and the loss of ice cover. Heat is an extremely important constituent in chemical reactions. Heat increases kinetic energy of molecules, which in turn increases reaction rates. External temperature has an effect on internal temperature as well. As temperature increases, enzymatic activity increases as well. As enzymatic activity increases, your metabolism increases, which uses up more oxygen, leaving less available in the environment. However, excess heat can cause protein denaturation, which can eventually lead to cell death.
Temperature changes can also alter the toxicity of different substances by either increasing or decreasing their effectiveness. For example, O-chlorophenol's effectiveness decreases at higher temperatures, requiring a higher dosage to have the same effect as a lower temperature. Reactions due to the addition of pesticides and heavy metals increase rapidly with warmer temperatures. There is also a complex interaction between the solubility of heavy metals and oxygen concentrations. Because heavy metal solubility depends on their oxidation state, oxygen concentrations have a hand in regulating their solubility. Reproduction can also halt in warmer waters due to unfavorable conditions. Unfavorable conditions can also cause organisms to migrate to areas better suited for them, resulting in biodiversity loss in the aquatic ecosystem.
Now that we've covered the effects of thermal pollution, I want to spend the rest of the time talking about ways to control or reduce the impacts of thermal pollution. Since the industry has a big hand in causing thermal pollution, they definitely should be held accountable. One thing they can do is build cooling towers. So cooling towers are an energy-efficient and cost-efficient way of cooling water. I did mention once-through cooling in the beginning and how that was bad for the environment, but now I'm going to touch on the cooling towers.
The way these towers work is air enters the tower and passes through the water. Heat exchange occurs between the two and some of the water also evaporates. This evaporation exits through the top of the tower and the cooler water gathers at the bottom of the tower. The cooler water can then be pumped into a river or a nearby water body or can be pumped back into the building for reuse.
Alternate cooling methods like dry cooling can be used as well. In dry cooling, instead of water being the medium, air is actually the medium. Dry cooling is very useful in areas that have a limited access to water. In dry cooling, a strong gust of air is forced through tubes in a condenser, and as the air passes, heat is directly transferred to the ambient air.
Another thing factories can do is build cooling ponds. Cooling ponds are shallow ponds that have a large surface area to volume ratio, allowing heat loss to occur easily and more efficiently. Cooling ponds are typically used in areas where land is cheap or where other cooling methods are more expensive, or even if there are strict laws on thermal loading.
This next approach isn't the most practical one in the world we live in today, as it requires a group effort, but perhaps it's a more hopeful approach. By saving electricity or using less would be produced by factories, resulting in less pollution. However, this only works if everyone were to use less, or perhaps use a more sustainable source of energy like solar energy.
The last method I will be talking about is reforestation. So afforestation or reforestation techniques can also be used to help with the issue of thermal pollution. Trees provide somewhat of a barrier between water bodies and sunlight, and as we know, the sun does in fact warm water and can possibly act as a stressor. It would act as a stressor in an environment that was previously shaded and for whatever reason no longer is. Planting more trees would re-establish the lost shade and would make the water cooler as well. In general, trees are important in having a stable ecosystem and have more benefits than just providing shade.
So that's it for today. I hope you enjoyed this very high budget video that I filmed in my room, and I hope you learned a little more about thermal pollution. What I got out of it is that humans are ruining the earth and who knows how long we'll live, but alas, there are some things we can do to prolong that near doom.